Hello everyone. Today we are going to continue our discussion related to entity relationship model. In the last session we have covered few of the concepts related to ER model. So let me list out those concepts first. So we have seen what we mean by entities, entity sets, attributes, types of the attributes, relationships, relationship sets, degree of the relationships, and also we talked about the concept of participation. So today we are going to continue our discussion and will be focusing upon few more concepts related to ER model. So let's begin with constraints. Whenever we draw ER model, our ER model can be drawn such that it may define certain constraints to which the contents of the database must conform. So today we are going to talk about two kinds of constraints. First is mapping cardinalities and second is the participation constraints. So let's look at the mapping cardinalities. Mapping cardinalities are also known as the cardinality ratios. Mapping cardinalities are also known as the cardinality ratios, and these mapping cardinalities express the number of entities to which another entity can be associated via a relationship set. So what we mean by that? Let us assume our example. So in our running example, we are having university schema, and in university schema we are considering the instructor entity set, the student entity set, and the advisor is the relationship set between these two entity sets. So considering this example, let me explain you what we mean by the mapping cardinality. As we stated, it is the number of entities to which another entity can be associated via a relationship set. Meaning, if I consider one student, then that is one entity. So I am going to find out to how many other entities, for example instructor, how many different entities like instructor, that student is associated with the relationship advisor. Or in other words, I may say that I need to consider, say for example, entity as instructor. So to how many students one instructor is being associated via this relationship set advisor. So in general, whatever is this number of entities to which another entity can be associated is called as the mapping cardinality, or it is also called as the cardinality ratio. So whenever we describe a binary relationship set, this concept of mapping cardinalities is really meaningful and most useful to describe this binary relationship sets. So what we mean by binary relationship sets? Binary relationship sets are the relationship sets wherein two entity sets are participating. So we have seen earlier the concept of degree. So if in a relationship set two entity sets are participating, then we say that the relationship or the relationship set is binary or having degree 2. So, if we are dealing with the binary relationship sets, this concept of mapping cardinalities becomes most useful. For such binary relationship sets, we are having several kinds of mapping cardinalities. So what are those? We may have one-to-one cardinality, one-to-many, many-to-one, or many-to-many. So binary relationship sets may have the cardinality of one of these kinds: one-to-one, one-to-many, many-to-one, and many-to-many. So we are going to talk about all those different kinds of mappings, and also we are going to discuss those concepts of mapping cardinalities with the examples. Right? So let's proceed with the pictorial representation of mapping cardinalities. So let us assume that we are having two entity sets. So what are those two entity sets? I am having entity set A and I am having entity set B. So whatever you see here, A1, A2, A3, A4, these are the entities from entity set A, and B1, B2, B3 are the entities from entity set B. Okay, now let us see in this scenario what we mean by one-to-one mapping cardinality. An entity in A is associated with at most one entity in B, and an entity in B is associated with at most one entity in A. If this is the case, then we say that it is one-to-one mapping cardinality. So let's relate this concept of one-to-one mapping cardinality with our example. So let us assume that we are having two entity sets, instructor and student, and let us assume that we would like to impose a condition. And what that condition is? We are having the condition like every instructor will be advising at most one student, and every student must be associated with at most one advisor. I'll repeat. This is just the assumption. Just for the sake of understanding, I am imposing one condition, or I am stating one scenario. Like, let us assume that we are having the condition like every instructor will be associated, or every instructor is advising at most one student, and every student is associated with at most one advisor. So if this is the case, then we say that the advisor relationship which is there in between the instructor and student, so the instructor and student entity sets are related with this advisor relationship, and if we are supposed to impose this condition, then we will say that advisor relationship is having one-to-one mapping cardinality between instructor and student. Right? So let me repeat once again. So what we have? We are having the entity set, that is instructor, right? And we are having another entity set that is student, right? And in these two entity set or these two entity sets are related with the relation. And what is that relation? That relation is the advisor relation. Okay, so what we are saying is we are imposing the condition like one instructor is associated with at the most one student via this relationship advisor, and also one student is related with at most one instructor via this relationship advisor. And if this is the case, then we say that this advisor relationship, which is a binary relationship between two entity set instructor and student, is having one-to-one mapping cardinality, right? So I hope you must have understood the concept. So let's proceed with the next kind of cardinality constraint, and that is one-to-many. So what we mean by one-to-many constraint? Let us first define it. An entity in A is associated with any number of entities in B. I'll repeat. An entity in A is associated with any number of entities in B. However, an entity in B can be associated with at most one entity in A. I'll repeat. An entity in A is associated with any number of entities in B, including 0. However, an entity in B is associated with at most one entity in entity set A. So if you look at this figure, what we have, once again we are having two entity sets A and B, right? So A1, A2, A3 are the entities belonging to entity set A, whereas B1, B2, B3, B4, B5 are the entities in entity set B. So what we mean by one-to-many relationship? So if we look at this entity A1 from entity set A, then this entity is associated with any number of entities in B. So here A1 is associated with B1 as well as B2. A2 is associated with B3 as well as B4. A3 is associated with B5, right? So entity in entity set A can be associated with any number of entities in B, including 0. So what I mean by that, if I am having one more entity here, say A4, if I am having one more entity in A, and let us assume that this entity is A4 entity. Okay, so if I am having this entity and if it has not been associated with any of the entities in B, then it is okay, right? So this is what we mean by any number of entities in B. So an entity in A is associated with any number of entities in B, including 0. However, entity in entity set B can be associated with at the most one entity set, at the most one entity in A. So this means that here B1 is associated with only one entity A, that is A1. B2 is also associated with only one entity in A, that is A1. B3 is associated with A2. B4 is associated with A2. B5 is associated with A3, right? So every entity in B is at the most associated with only at the most one entity in entity set A. So this is what we mean by one-to-many relationship or one-to-many cardinality. So let us try to relate once again this concept with our running example, instructor and student. Okay, so let us assume that we are having here the instructor entity set. Okay, so A is my instructor entity set and let us assume that B is my student entity set. Right? Now, what I am imposing here, one-to-many constraint. So, what we mean by that? And we are imposing this constraint on the relationship set advisor. Right? So, in between these two, we are having the relationship set, that is advisor. So, what we are saying is every instructor. So, let us assume this A1 is my instructor. So, this instructor, that means this entity, is associated with any number of students. So, one instructor is associated with any number of students, maybe 0, 1, 2 up to n, whatever it may be, right? So, instructor is associated with any number of students, but every student is associated at the most one instructor, right? So, this B1, if B1 is a student, this B1 is associated with only one instructor, that is A1, nothing more than that. B2 is associated with A1, right? But B2 is associated at the most one instructor, and here in this case it is A1, correct? So, once again I will repeat the definition of one-to-many. An entity in A is associated with any number 0 or more of entities in B. However, an entity in B can be associated with at most one entity in entity set A, right? So, sometimes it may happen that we are having here one more entity in B, say B6, and that has not been associated with any of the entities in this instructor relationship, instructor entity set. It may also happen, right? Or vice versa. It may also happen that I am having entity in A and that has not been associated with any of the entities in B, or I am having entity in B and that is not at all associated with any of the entities in A. It may happen. Okay. So, in this scenario, I will say that my relationship set advisor, right, is one-to-many from instructor to student, right? So, one instructor may be associated with more than one students, but one student is associated with at the most one instructor. That's all. Okay. So, I hope you must have understood the concept. So, let's proceed with the next kind of mapping cardinality, and it is called as many to one. So, it is exactly opposite of whatever we discussed about one-to-many. So, in contrast to one-to-many, we are having this many-to-one cardinality, wherein what we are saying now, an entity in entity set A is associated with at most one entity in B. However, an entity in B can be associated with any number of entities in entity set A. Right? So it is exactly opposite to whatever we discussed for one to many. So now in this case, let us assume that this A is our student and this B is our instructor, and we are talking about the relationship set in between these two, that is advisor. So student is the entity set, let us assume this is A, and entity set instructor is B. So what I am saying now, one student, right, one student is associated with at most one instructor, right, but one instructor can be associated with any number of students, right. So from student to instructor, this relationship set advisor can be seen as many to one. One student is related with at the most one instructor, whereas one instructor can be associated with any number of students including 0, right. So if I talk about this advisor relationship, right, it is one to many from instructor to student, but it is many to one from student to instructor. I hope the concept is clear, right. If there are any doubts, you may report me. Okay. Now let us proceed to the last kind of mapping cardinality, and that is many to many. So what we mean by this many to many mapping cardinality? So obviously, as this name suggests, many to many, an entity set A and an entity set B is having associated with some relationship set. Okay. So an entity in entity set A is associated with any number of entities from entity set B, and an entity in entity set B is associated with any number of entities in entity set A. So please look at here, A1 is the entity from A and that is associated with B1 and B2, right, many number of entities it is possible. And also if we look at entity from entity set B, it is also associated with many number of entities from entity set A. So if this is the case, then we say that it is many to many. So once again, if we look at our instructor student relationship, right, if this is the case that it is allowed that one student may be associated with any number of instructors and one instructor can be associated with any number of students, then we say that it is the many to many relationship. I'll repeat, if we allow more than one instructors for one student to work as advisor, and if we allow that one advisor, one instructor can instruct or advise more than one students, then this becomes many to many cardinality, or this becomes many to many relationship, right. So I hope you must have understood these concepts, right. So overall 4 kinds of mapping cardinalities: one to one, one to many to one, and many to many, right. So after looking at the constraints known as mapping cardinalities, let us proceed to the other kinds of constraints, and those are known as participation constraints. So under participation constraints, we have two kinds of constraints. First, known as total participation, and second is known as partial participation. So let us see one by one what we mean by that. So what is total participation? If every entity in the entity set participates in at least one relationship in the relationship set, then we say that it is total participation. I'll repeat. Every entity in the entity set participates in at least one relationship in the relationship set, then we say that it is total participation. So let us see the example now. So in our running example, if we say or if we look at the participation of student entity set, participation of student entity set in the relationship set advisor, what we can say about this participation? So we are having student and we are having instructor, and these are related with the relationship advisor, right? So if we look at this relationship advisor and this entity set student, we say that every student must have associated at least one instructor. This is my student and this is my instructor. So what I am saying? I am saying that every student must have associated with at least one instructor who is working as advisor. So in this situation, every student is participating in this relationship set, meaning for every student we are having one relationship in this advisor relationship set. So this entity set student is having total participation in advisor relationship set, right? So this is what we mean by total participation. So participation of student in advisor relationship set is total, meaning every entity in the entity set is participating in at least one relationship in the relationship set, right? So every student is having associated with at least one instructor, and that is why we find every student, right, in this advisor relationship. That is why we say that it is total participation, right? Now let's proceed with partial participation. So what we mean by partial participation? Some entities may not participate in any relationship in the relationship set. If this is the case, then we say that it is partial participation. I'll repeat. If some entities are not participating in any relationship in the relationship set, then we say that it is partial participation. So let us see once again the similar example. Suppose once again we are having the student entity set, instructor entity set, and the relationship between them is advisor. So it may happen sometimes that few of the instructors are not advising any of the students. Few of the instructors are not advising any of the students. So in this situation, we say that participation of instructor in advisor relationship is partial, because there are some instructors who do not participate in any of the relationship in this relationship set advisor. Few of the instructors are not associated with any of the students as advisor, and that is why these instructors will not be there in this advisor relationship, and that is why we say that participation of instructor in advisor is partial, right? So I hope you must have understood the concepts. Okay, so now let's see the concept of keys. This is really very important concept. There are various kinds of keys, those we are making use of while describing the database systems. Today we are going to introduce these various kinds of keys, right? So today I am going to introduce the keys, and later on whenever we once again go for relational database schemas, then we'll be once again having the detailed discussion about the keys. But now let's see the concept. Okay, so whenever we are storing some data in the database, we must have some way to specify the distinction between two entities. Suppose we are having, say, student as one entity set or instructor as one entity set. Then whatever data that I am storing under instructor entity set or whatever data I am storing under student entity set, I need to distinguish the entities from one another. And to distinguish the entities from one another, we need to have some way according to which it is possible for us to distinguish. Meaning, we should distinguish those entities stored in the entity set with the help of some attributes of that entity set. Okay, so usually the values of the attributes of an entity, the values of the attributes with respect to various entities stored in the entity set are different, and we should have some attributes or at least one attribute that will help us to distinguish two entities from one another, right? Or in other words, we may say that no two entities in an entity set are allowed to have exactly the same values for all attributes. I'll repeat. No two entities in an entity set are allowed to have exactly the same value for all the attributes. If it happens, meaning these two entities are same, right? So we are not storing the duplicated entries, right? So to store the data in our entity sets, what we want is, we want that no two entities in an entity set should have exactly the same values for all the attributes. So This is how we come across the concept of keys, right? So what are the keys, or what is the key? Key is used to identify the set of attributes that suffice to distinguish entities from one another. Or we may say that keys uniquely identify the entities. So to distinguish the entities from one another, we need to have some kind of unique identity for every entity that is stored in entity set, and this attribute or set of attributes is known as the key, right? So we are having, as I stated, we are having various different kinds of keys, right? So one by one I am going to introduce you these different kinds of keys, right? So we have understood what is meaning of a key. So what is a key? Key is a unique identifier for the entity. I'll repeat, key is the unique identifier for the entity. Say for example, if I am having instructor as one of the entity sets, right, instructor, then I am storing several instructors or the data related to several instructors in this entity set, and what I want is, I want to distinguish one instructor from another instructor. So to distinguish this data from one another, what I need at least one attribute that will identify uniquely that particular entity. So let us assume that we are having, or the instructor is having, the attributes like ID, name, right, and salary. So what are the attributes for instructor? We are having ID of the instructor, we are having name of the instructor, and we are having the salary of the instructor. So let us assume that these are the three attributes of instructor entity set, right? So I need to identify the attribute that stores unique value for every instructor. Say for example, if I consider ID, right, then whether ID can distinguish two entities, whether ID can differentiate two entities? Yes, because we are assuming that every instructor is having unique ID, and that is why we may say that ID can be a key for this entity set instructor. Now let us look at the concept of super key. So what is super key? Super key of an entity set is the set of one or more attributes whose values uniquely determine each entity, right? So no doubt ID is my super key, because if I consider ID, then it is possible for me that the value of the ID, if I consider, then it can distinguish between two instructors, right? So ID is the super key for the instructor. But if I consider the set of attributes, say ID along with name, ID along with name. So once again, if I am having this set of attributes ID and name, then also it is possible for me to distinguish two instructors from one another, right? Even if I say that I am having the set of attributes ID, name and salary. So once again, if I consider this group of attributes together, then also it is possible for me to distinguish two entities from one another, to distinguish two instructors from one another, and that is why I may say that this group of attributes, say ID, name and salary, it is also a super key, right? So once again we'll repeat the definition of a super key. A super key of an entity set is a set of one or more attributes whose values uniquely determine each entity. So in case of our instructor entity set, we are having ID, which is a super key. We are having set of attributes ID and name, that is also a super key. Or even if we are having the set of attributes ID, name and salary, that can also be treated as super key. Now, after understanding the concept of super key, let us talk about the candidate key. So what is candidate key? A candidate key of an entity set is a minimal super key. It is a minimal super key. So what we mean by that? Now, if we look at the super keys, those we have identified. So we have identified ID as the super key. We have identified ID and name together, that can be used as the super key for the instructor entity set. Or even we have identified that ID, name, salary can also be treated as the super key. Now, if I am having all those super keys, what I am going to do next is, I am going to find out a super key for which I do not have the proper subset that is also the super key. I'll repeat. I'm going to find out the super key such that no proper subset of that super key is also the super key. What I mean by that? Say for example, whether ID along with name can be treated as candidate key, whether it is a minimal super key. If I consider the combination ID and name, right, which is a super key, okay, so whether it is possible for me to find out any proper subset of this super key, and that is also distinguishing two entities in my entity set. I'll repeat. If I consider this set of attributes ID and name, is it possible to have a proper subset of this set? Yes, it is possible. So what are the proper subsets of this set ID and name? I may have ID, only ID as one subset, correct, and I may have name, that is also one subset. Okay, now if I am having these two subsets, right, proper subsets, what I need to find out is whether any of these proper subsets can form the super key, meaning any of these subsets can be treated or can be used individually to distinguish two entities. Yes, if I consider this proper subset ID, then ID only is sufficient to distinguish two entities in my instructor entity set, and that is why I may say that ID, which is a proper subset, is also sufficient, and that is why ID along with name cannot be treated as the candidate key, right? ID along with name cannot be treated as the candidate key. Why? Because in this super key I am having the subset of this super key that can also be treated as the super key. So subset of this, that is ID, is also the super key, right? And in this subset I am having the single attribute, so I may not have any other subset of this ID, and that is why I may say that ID is only ID if I consider it is a minimal super key, and that is why I may designate this ID as the candidate key, right? But if I look at this combination, this super key ID and name, right, I am having two proper subsets. Name cannot be sufficient to identify or to distinguish two entities from one another, because it may happen that there are two instructors having the same name, but the proper subset of this super key, that is ID, is sufficient to distinguish that. Okay, and that is why I may say that ID name is not my candidate key, but only ID is my candidate key. Okay, now let me give you one more example. Suppose let us assume that we are having the combination of name and salary. We are having the combination of name and salary. So these are the two attributes, and let us assume that these two attributes, okay, are forming my super key. What we mean by that? See, just I mentioned that only name if I consider, then it is not possible for me to distinguish two instructors, right? Because it may happen that two instructors are having exactly the same names, right? So name cannot be treated as the super key or the key, right? But if I consider, or if I assume that if two instructors are having same names, right, they are having different salary always. Let us assume, this is my assumption and this may not be the reality, but just to understand the concept I am giving you one example. Let us assume that if I am having two instructors with same name, say for example we are having two instructors with name A, I am assuming that if this is the case, then their salaries are different. So if the first instructor with name A is having the salary say 50,000 and the other instructor having the same name A is having the 60,000 salary. So we are assuming that no two instructors with same name are having same salary. So this is our assumption, and with this assumption we may say that now name salary is my super key, because if I consider this combination name along with salary, right, as I mentioned, even though the names are same, the salaries are different, and that is why this combination name salary can be treated as one more super key with this assumption, right? Now if name salary is also one super key, now let us try to find out whether this super key is the candidate key. Whether this super key is the candidate key. Now if we consider this super key, according to our definition, candidate key is a minimal super key. So what we mean by that? If we try to find out the proper subset of this super key, and if it happens that that proper subset is also the super key, then we may say that this original super key that we are considering is not the candidate key. Okay, now whether this name salary can be treated as the candidate key. Now if I consider only name, which is the proper subset, is it possible that this name can distinguish two entities? No. If I consider only this proper subset, that is salary, whether this only attribute salary now can distinguish two entities? No, because it may happen that two instructors may have the same salary. Our assumption is no two instructors having the same name are having same salary, but two instructors having different names may have same salary. That is what our assumption is, and according to this assumption we may say that even though if we try to find out a proper subset of this super key name comma salary, it is not possible for us that we come up with a proper subset that is also the super key. So only name is not the super key, only salary is not the super key, but if we consider name along with salary, then it is a super key. Okay, and as there is no proper subset that can also be treated as the super key, we may say that this name comma salary is one more candidate key for my entity set, that is instructor. Okay, so we may have more than one candidate keys for entity set. We may have more than one super keys, we may have more than one candidate keys also. The candidate key is the minimal super key. And what we mean by minimal super key? Candidate key is always super key, right? But if we look at the super key, and if it is not possible for us to come up with a proper subset of that super key that is also the super key, then we say that that super key is the candidate key. So this is how, for the given example and with given assumptions, we may say that ID of the instructor can be treated as the candidate key. Similarly, name salary combination can also be treated as the super key, candidate key. It is a super key and that can also be treated as the candidate key. So one entity set may have more than one candidate keys. Now let us look at the concept of primary key. Although we are having several candidate keys for entity set, one of the candidate keys is selected and that is designated as the primary key. So out of several candidate keys, we are going to pick up one candidate key and we are going to designate that candidate key as the primary key. And typically the primary key should be chosen such that its attributes are never changed. Or we may say that the primary key should be chosen such that the value of this attribute, even though it changes, it rarely changes, right? So we should pick up such a candidate key as the primary key such that its value never changes, and even though it changes, then the change is very rare. Okay, so if I am having two candidate keys now, those are identified for this instructor entity set, and those candidate keys are ID and name salary. Okay, now even though we are having these two candidate keys, we will prefer to use ID as the primary key for this instructor entity set, and the reason is ID typically is unique for a particular instructor, right? But if we select name salary as the candidate key, there are the chances, right? At some moment of time, it may happen that two instructors having the same name may have same salary. It may happen sometime, and that is why instead of choosing name salary as the candidate key, name salary as the primary key, we prefer to use ID as the primary key, right? So I hope you must have understood the concept. If you have any doubts, please report the doubts if any. Okay? Now, we have talked about the concept of keys with respect to the entity sets. But let me tell you that the relationship sets are also having the keys. The relationship sets are also having the keys. So, how to identify the keys for the relationship sets? So, always few of the entity sets are participating in the relationship sets. I'll repeat, few of the entity sets are always participating in the relationship sets. So let us assume once again our example. So in our relationship set, that is advisor, two entity sets are participating. And which are these two entity sets? The student entity set and the instructor entity set. Okay, now if we consider now this relationship set advisor, and if we want to find out the super key for this relationship set advisor, then what we can do is we can find out, or we can have the combination of the primary key of the student and the primary key of instructor entity set. And this combination of the primary keys of the participating entity sets will form the super key for the relationship set advisor. I'll repeat, if I want to identify, or if I want to find out the super key for the relationship set, then how I am going to choose the super key for the relationship set? Whichever are the entity sets, those are participating in that relationship set. We collect the primary keys of the participating entity sets and we are able to form a super key for that relationship set. Example, advisor is the relationship set, student and instructor are the entity sets, those are participating in advisor. So S_ID is the primary key of student and I_ID is the primary key of instructor. So if we combine these two primary keys, then this will form the super key for my advisor, right? Now, in general, if we want to define the relationship set R, right, or if we would like to know the attributes of the relationship set R, right, then how we are going to describe this relationship set? Let us assume that we are having n number of entity sets, those are participating in the relationship set R. Okay, and let us assume that we are not having any attribute of its own with that relationship set R. Let me remind you, we have seen earlier that the relationships can also have their own attributes. Okay, but let us assume that the relationship set is not having its own attribute, right, but there are n number of entity sets, those are participating in the relationship set R. Now, in this scenario, we are going to describe this relationship set R as the union of the primary keys of all participating entity sets. So if E1, E2 up to En are the entity sets, those are participating in the relationship R, then the primary keys of all those entity sets together will form that relationship set R. Okay. Now, in the other scenario, if the relationship set R is having its own additional attributes, say A1, A2 up to AM, then this relationship R having its own attributes is described as the union of the primary keys of the participating entity sets along with the set of attributes A1, A2 up to AM. So, I'll once again want you to recall back. The relationship may have its additional attribute. Say for example, if we are talking about the advisor as the relationship, then we have seen earlier that this advisor relationship may have its own attribute. Say for example, date of association between the student and the instructor. So if we want to store that additional information, we may have the additional descriptive attribute for the relationship set. Okay, so let us assume that this set of attributes A1, A2, AM is the set of attributes associated with that particular relationship. So if I am having any such attributes associated with the relationship, then that relationship actually is represented by making use of this expression, union of all the primary keys of participating entity sets along with the attributes of that relationship, own attributes of that relationship set are. Okay, so this is how we are describing the relationship set, right? And I'm just making you aware of one concept. We are not going into the details right now. If this is how I'm going to define or I'm going to describe my relationship set R, then not only we are having the super keys for the relationships, but we may also have the candidate key and the primary key for the relationship sets. So if we want to find out the candidate keys for the relationship set, then we need to consider the mapping cardinality of the relationship set to decide the candidate keys. I'll repeat, we need to consider the mapping cardinality of the relationship set to decide the candidate keys, right? And also, if we would like to find out the primary key for the relationship set, then we need to consider the semantics of the relationship set, right? What we mean by that? As I mentioned, we may have more than one candidate keys for relationship sets also. So if I am having more than one candidate keys for the relationship set, then I need to consider the semantics of the relationship set, and whichever is the most relevant candidate key, that I need to pick as the primary key for that relationship set. We are not going into the details right now. So later on, whenever we are going to discuss the relational schema or the relational database model, then we are going to focus upon these concepts at greater depths, right? So I hope you must have understood those concepts. So let's stop today. Thank you.